evening, dear viewers. Thanks for watching. This video is part 2 in a series of videos I am creating on the PIC18F4525. Please see the playlist on my channel for the PIC18F4525. I always like to start by saying I am not an expert, but I am a genuine enthusiast. So, indeed, this is a video of me learning. I am delighted to share my experience with you. In particular, this video is me gathering relevant information on the PIC18F4525. You might argue that everything included in the data sheet is relevant. I agree. However, the data sheet is 412 pages. So, the information included herein is what I feel is helpful and interesting for getting started with the PIC18F4525. And yes, this video may be a little boring, but supposing you are trying to learn about this chip, I feel it's useful. The 18F4525 is an 8-bit microcontroller. Inside of the chip, in a roundabout way, the GPIO pins and ports are connected to registers called Special Function Registers, SFRs for short. Each SFR is configured through the use of 8 bits. This is why the 18F4525 is an 8-bit microcontroller. This 40-pin chip features up to 10 million instructions per second. I don't know how that measures against other devices, but it sounds fast to me, and it's good enough for me. It has C compiler optimized RISC architecture. It has an internal oscillator which supports 31 kHz to 8 MHz with 4 times phase-locked loop. Compare this to previous and similar chips which do not contain an internal oscillator, specifically the PIC18F452. The 18F4525 has a wide operating voltage range, 2 volts to 5.5 volts. Speaking of operating power, the data sheet speaks at length about various power-saving features, such as the watchdog timer, idle modes, and sleep modes. None of these do I attempt to discuss herein. I'm just pointing out that consumption of power usage is a feature which has been developed in various different ways in this chip and similar ones. The 18F4525 has a 10-bit ADC with 13 channels at 100K samples per second. It supports eUSART, SPI, and I2C. It has up to 5 PWM outputs. There's also some capture and compare features which I haven't fully studied yet. The 18F4525 has a program memory size of 48 kilobytes and about 4,000 bytes of SRAM. Compare this to the Arduino Uno, or rather the Atmega 328P. The Arduino has only 32 kilobytes of flash memory and 2 kilobytes of SRAM. although both the Arduino Uno and the PIC18F4525 have about the same data EEPROM of 1 kilobytes. As I said before, I am gathering this information on the PIC18F4525 with a focus on what is helpful and interesting for getting started. If you are a computer science student, you may have an even superior learning compared to my own. I think it's important to cover both the ADC and the oscillator. This is because you will need to set the special function registers in your program for both the ADC and oscillator before you can start writing your code. But if I start going into detail on those, this video is going to get very long. So I think I'm going to save those discussions for separate videos, which are coming ahead. Just as a last comment, I just wanted to say that a great way to study the capability of any chip, particularly the 18F4525, is to examine the different pins and their description. This can be found on page 12 of the datasheet. And for example, say on page 18, I learned port B can be software programmed for internal weak pull-ups on all inputs. Well, that's very useful. This interests me here, and I haven't quite figured it out yet, but page 9 of the data sheet has a table listing different features, and I noticed that when talking about the I/O ports, it mentions A, B, C, and E. So what happened to D? I'm not making jokes, I'm seriously asking. When I scroll down to page 20 of the data sheet, and it starts describing each of the pin names and their description, it says port D is a bidirectional I/O port, or a parallel slave port, PSP, for interfacing to a microprocessor port. These pins have TTL input buffers when the PSP module is enabled. Well, that's fine, but can these pins on port D still be used as digital I/O pins? Well, it seems like they can, as the description for each of the subsequent pins says that they are digital I/O. So I'm not sure what the issue was on page 9 of excluding port D, but I'll leave it at that. Thanks for watching, and stay tuned because I fully intend to make separate videos on the analog to digital converter and a separate video on the oscillator. Thank you very much. Stay tuned. I am learning myself, and thank you very much for learning along with me. Have a good day.